Hello and welcome back. In the previous module, we discussed how to translate the schematic file into a PCB file, and I showed you that's quite straightforward. First, confirm that there is a footprint connected to each and every symbol added here in the schematic, and then use this option update PCB and make sure that you have a project file, and within the project file you have a schematic as well as a PCB file. So this file name appears only if you have a project file and that PCB file is attached to this attached within this project. If you haven't added any project file, you can create a new sorry, if you haven't added a PCB file, you can add new PCB file here to this project. If you have an existing file and you want to add, for example, I want to add an existing file, for example PCB1. I'll just open it, and now I can show you that I have two files, PCB files. Okay, this is the second one, and I have another one, test PCB. So I can just save this, and let me remove one of them. Let me remove the previous one and let me keep the new one that I just added. Alright, so I'll just close this and keep the new one. Alright, so in today's module, the focus is on the PCB environment. Okay, the PCB editor, and we'll explore the different options that we have here, starting with the this ribbon down here. You can see that the first two shows you the layers, the top layer and the bottom layer. Okay, so the top layer is the top of the PCB, and you can add some traces on this layer, and you can also add traces to the bottom layer. The other layers, for example, important layers are the top overlay, and you can see the text in the yellow, and these lines they are printed on the top of the PCB, but on the top side of the PCB. Similarly, we have the bottom overlay, and the whatever we uh, whatever text are the any graphic stuff we put on the bottom will be printed on the bottom overlay. And similarly, we have the top and the bottom solder paste mask, okay, solder mask. And similarly, okay, these are the important layers. Okay, so maybe you might be feeling quite that this is quite complicated. So to make things easy, you can enable and disable. You can just press L on your keyboard, and it displays this kind of window. And from here you can choose which layer you want to display, and which one you want to make invisible. For example, I want to make these mechanical uh, layers invisible. Similarly, these guys. Okay, and even let me disable these. So have a look at the bottom. What you can see at the bottom is that now you are left with only the top and the bottom layer. Okay, if you disable the other layers. So it's good to enable the top overlay. Okay, now you can see the yellow comes there, and the bottom overlay, and even the solder mask. Okay, so now you can see at the bottom we have the metal, the top and the bottom metal, the overlay, and the solder mask. Alright, so we can disable this, and whenever you want to invoke this, you can just press L on your keyboard. Another way you can do this is just by right click somewhere on this ribbon, and you can press hide. Okay, and you see it's gone. And now if you want to show that, you can come here and then enable again. Similarly, you can go to this option and you can see here that you can uh, hide these layers, and in the show section you can go and um, enable those that I have just disabled. So that's how you can make your environment up to your requirement. Okay, another thing that I want to discuss here is that you can that all the components now I have placed is on the top layer. Okay, that's if you want to make a single layer PCB, or you want to place every component on the top. All the SMTs will be soldered to the top of the PCB, and the whole through package. We can solder them. These are you need to have holes in your PCB for that. But if I want to utilize the space, want to utilize the space up to potential, then I better use even the bottom layer. For example, if I want to push any of these components, let the this input barrel jack, if I want to push it to the bottom, I need to just press L on my keyboard, and you can see that the color of those pads changed to blue. Okay, let me place it and let me show you something. The top layer, the color, the red pads shows here, that the red pads show that it's that these components are on the top layer. They'll be soldered to the top of the PCB, but the blue shows the bottom layer. Okay, this component will be soldered to the bottom. Another thing now you can notice here that the yellow color is for the top overlay, and the color for the bottom overlay is a little bit different, as you can see now that the overlay color is no longer yellow. Okay, so it's a different color. So that's the difference, that when you can that when you push it to the bottom, you can bring it to the top once again by pressing L and place it again somewhere here. Alright, so you can move your components either to the top or the bottom, and look for the best position, so you can minimize the board size. Okay, because the board size directly determines the cost of the PCB. Okay, another thing I want to show you is, just like I showed you that the black here represents, the red represents here the top, and the blue represents the bottom copper. If I want to put a track here, so I'll go to interactively route connection, and I'll just select this guy, and let me draw a track between these two. Okay, we'll do that later, but let me show you something. Now this track will be printed on the top layer, right, because it's red. Or if I want it to be in blue, let me just delete this one, and let me use blue instead. Okay, blue doesn't mean just a color, it in fact means the different side of the PCB. So again, I'm going to use this very same interactive routing tool, but this time when I start, again it's red. Okay, and you need to press L key on your keyboard and it turns blue. Okay, it means you are switching the layer. Okay, so again red and then blue. So you can change the layer just by pressing L. don't worry, you just start your drawing your track, and um, you can change the layer just by pressing the key F on your keyboard. Okay, so now another thing I want to show you is that although uh, it's not a good example. I mean, the track that I'm selecting, for example, I'm drawing a line from here to here. Since we cannot cross, the blue line cannot cross the blue line, the the red line, the red track cannot cross the red track, because that, unless they belongs to the same net. So otherwise they'll mean this means a short circuit. So for instance, let we are facing a situation in which we have no other option, but this is, for example, this is the only way to get to some destination here, let's say. So for that, what we normally do is we put a via and switch to the top layer, or for example, if we are working on the top layer and we are about to cross a another track on the top layer, we just switch the layer and go to the bottom and then complete that track. So for instance, here I want to complete this track, so I'll put a via here. So to put a via, you can press a static on the keyboard, and you see that via has been appeared. I can just put it here, and now from here on you can see that the track is now red, and I can take it to the desired location, and you can see that I have completed my track. Alright, so you can do this is you can use this technique, and remember that you can use static to input the via, and the other way you can do is, let's say, place a via before starting your track. You can set the size. Okay, for example, you can set the diameter, let's say 35 mil. Okay, and then you can start your track, for instance, starting from here. Let me press L to turn blue, connect. Okay, so let me show you something nice. You can see that I'm not able to connect to this via, and what's the reason behind this is that the via doesn't have the same net uh, as this ground. Okay, it doesn't have the ground net. So if you want to use it for connecting that ground, you should assign it this net GND. So now let me try again. Okay, now you can see the GND is written, is displayed, and now let me show you. If I get there, you can see that I can connect, and from here on I need to press L to change the color, and then I can connect here. Okay, so that's how you can get to the destination without overwriting, without crossing an existing track. Okay, so now let's get into more detail. I showed you that the important things while routing your PCB, two things are important. One thing you encounter is the via, and the other thing is the track. Okay, so the the track size depends on the width of the track. Here it's 10, for instance. So sometimes you might need 20, you might need 30, but it depends on the current requirement. If you know that this line is this track is going to carry more current, so you need to have a wider track. For instance, if you this is a ground, so we'll prefer to have a 100 mil. Okay, so This is something we need to look at. Similarly, the via size, that's another important thing. So we'll just explore this. So have a look that I have changed the via width, the track width to 100 mil, and what happened here is that it has turned into something different. Okay, it is a blue line, but it is showing some plus plus there. It's a kind of, it shows some kind of violation. So what is this violation? So we'll introduce here the rules. Okay, so let's start with the rules. So you can go to design and rules, and here you can see different kinds of rules categorized. All right, so let's start with the routing, and in the routing we have again different kind of for example, for beer we have this kind of we have this rule, and similarly for width we have this rule. So in here, as you can see, I set the width of this track to 100 mil, but here the rule says that our width should be, the width of the track should be, minimum should be 10 and maximum should be 30. So actually what happened there is that we have violated this rule. So whenever you violate this rule, you'll face something like this. So that reminds you that actually you are violating a particular rule. So here you can set, for example, I'm going to set the minimum width to 10. Let me set it to 20, and then I'm going to set the preferred to, let's say, 50. Right, and have a look at this one is a little bit different in color. That's quite, it's a pink. So it's that's because that we are not consistent, right? Because we have the minimum at 20, the preferred is 50, but the preferred one is even more than the maximum width. Okay, so look at the, it says that some rules have incorrect definition, would you like to correct it? So that's the reason that it should be, for instance, let's say 120. So I set this for top layer, so even if I say okay, it's not going to make any difference because I set that only for the top layer. So let's just define the same for the bottom layer as well. Let me set this to 20, this one to 50, and let me set this to 120. Okay, and I'm going to press apply and okay, and now you can see that it's different now. And now what's the problem here? It says that if you zoom in, it says that the width of this track is less than 10 mil. So it's another violation. Alright, similarly this track, it says that the width is less than 20 mil. Right, so the reason behind this is we set the in the rules we set the minimum width to 20. All right, we draw this track before defining that rule. That's why the problem came in. So even if you are facing this problem, you can just set this to 20, and now you can see that you are clear. All right, so that's how you can define your rules. The rules gives you, the rules makes your job quite easy, and forbid you from making some silly mistakes. You can define rules before starting your routing. Similarly, we can go for another kind of rule, let's say vias. Okay, so we can define a via, let's say let's define a maximum of 250 mil. and the minimum is 24, and let's say the preferred is also 24. And I'm gonna use the hole size as minimum is 16, maximum is 200, and the preferred is also 16. Press apply and OK. Okay, so now we can place our vias according to those rules. Alright, so now check this out. I'm using this track to get to whatever. Let's get to this point. Okay, and I'll check out the width. It's the 50 mil. Okay, and now let's proceed, for instance, to place some via. Let me put a static, and let me just you can just right click and you can break that track placement. Let me just check out these specifications. The diameter of this via is 24 and the hole size is 16 mil. Okay, that's what I set in the rules. Okay, the preferred hole size is 16 and the preferred diameter is 24. Similarly, the preferred width I set was 50 mil, so that's why the track that I just added here is 50 mil. So you can use these rules to make your job quite easy. Okay, so here I'm going to show you one more thing, that's about the PCB layers. As I said, we have two layers, the top layer and the bottom layer. And to see more about that, we can get into the layer state manager here. Okay, I'll just close this. Okay, now here you can see the picture. We have the top overlay, and I showed you this in the yellow color, and then we have the top solder mask. All right, and then we have the top layer itself. Okay, so the top solder mask actually it's a protective layer on the top of this conducting layer. Okay, we put our tracks on this layer, then we have the protective layer, and then on the top of that we have the overlay, where we can print different designators and other things. Similarly, there is a insulator, dielectric 1, FR4 is the insulator used here. And then we have the bottom layer, and similarly that's symmetric. Then we have the bottom solder, the solder mask, and then we have the bottom overlay. So this is actually a two-layer combination. We can add a layer here just by right clicking, and then we can choose insert layer below. So we can add either a plane or we can add a signal layer. Please remember that when we add a plane, it means that you cannot put tracks on that. You can just divide that into sections. Okay, you can divide that into different sections, and we cannot put tracks on that. And let's have a look that what's the new arrangement now. We have again the top overlay, top solder mask, and top layer, and again we have the bottom overlay, bottom solder mask, and the bottom layer. And then there is a insulation, a dielectric 3 between the bottom layer and the layer 2. And similarly we have another conducting layer between a dielectric between top layer and the layer 1. So if you can see the this orange color, in orange color we have the conducting layers, and you can see here the type is signal for the top and the bottom one, and for the middle one it's the plane, because I chose the plane. And uh, as I said, that if you on the signal layer you can on the signal layer you can put those tracks, but on the power layer, on the planes, you cannot put lines. You can just divide them into different sections. So let me just save this, for instance. And please remember that this becomes now a 4-layer PCB. Previously it was a 2-layer when they were only the top and the bottom layer. So now you can see that in the bracket you have 1, and the bottom layer you have the in bracket you have 4. So in between there are 2 other planes, and you can press L to open this window, and you have these 2 more layers, these 2 additional layers. And now let me close, and now you can see that we have 1 2 3 4. This one and this one, the top one and the bottom, you can put your tracks on it. But when it comes to the layer 2 and the layer 3, these are planes. And for the planes, what we do, for example, this is the plane. Just select this one and draw a line. All right, draw a line, and now have a look. This one and this one, these are 2 different planes. Now that means we have divided this plane into 2 parts. Similarly, you can divide just by drawing these lines. You can divide into many other parts. Okay, and you need to assign net. For example, you want this part to be the ground. All right, so this makes your job easy. Just connect your ground directly to this plane. Okay, so that's the difference between a plane and a signal layer. On the signal layer, for example, this is a top layer. I can just use tracks to connect to 2 points. But for the when it comes to the power layer, the planes, you cannot use these tracks. You can just divide them into. Alright, I'll just select this guy, and then I'll just delete them. Okay, so depending upon your requirement, the circuit complexity, depending on the circuit complexity, how much complex your circuit is, you can increase the number of layers. For example, you want to route a PCB with many components, then it would be a good option to add another signal layer instead of using the power layer. So for our example, even the 2 layers are enough. So I think we better delete the middle layer, and even I'll delete this one. So I'm gonna save this stack-up information. I'll just close this, and now you can see that again we are reduced to 1, and the top layer as 1 and the bottom layer as 2. Okay, another rule that I want to discuss is about the clearance. You can see here in the design rules, electrical clearance, and here you can see this table, and here you can see that the clearance from one track to another. It's 10. From some SMD pad to a track is 10. From one SMD pad to another SMD pad. Similarly, from track to a via. So okay, so I just click and you can change it. So I have already changed it to 10, from 10 to 50, to show something that, for instance, this is my via, and the clearance distance means that the minimum distance between, for example, in a pad and a track. Okay, so I set here this to 50. I set this to 50. Similarly, if you want from SMD pad to some another SMD pad, from via to another via, okay, you can use this table. So what's how they make difference? So let me start a track and let me show you. If I want to draw this track, it's fine. Now let me get closer to this via and see that what's happening. If I go away from this via, no problem, but if I get closer so that I violate that rule, then see what's happening. Okay, so you can use this rule to ensure a minimum clearance between a track and another track, one track and a via, and from one via to another via, and many other options. All right, so I showed you previously that if you start from a, let's say, via or a pad, and you want to change the bottom the layer, for example, if you want to switch to the bottom layer, just press L. Okay, but if you want to start a track just like this, okay, you are not starting it from any through hole package, for example, like this, then pay attention that if you touch the if you click that pad, you'll automatically start on the other layer. Okay, for example, I select the blue, the bottom one, but when I click here, have a look that in the bottom top layer is selected and the track is automatically on the top layer. The problem is, for example, if I want to start here somewhere randomly, now the thing is, if I want to use the L key, it will not change unless I put a VR. Alright, and if you want to start like this, just switch to the bottom layer, and then you can place a line, a track on the bottom layer. So these are the different options that you need to know before start routing your PCB. So in the next module we'll cover how to completely route these tracks, okay, and to make sure that we don't miss any of those. And since we have declared our rules in this particular module, so they will help us in the next module, and we can easily route our PCB. The one thing you might heard of is the automatic routing. Okay, and that's quite straightforward. You can use automatic routing, but that's not always useful, because there are some tracks that you want to be closest. You want them to be preferred while tracking, but they might not be. Okay, so you can use the automatic routing So for auto routing, you can just go to root, auto route, and then press all. Okay, you can just press then. There are some options. You can define the rules. You can enter your rules here before going forward, and then finally you can click route all, and it will start routing one by one, and on this all it routes all the tracks. And when done, you can close here and have a look. It has completed your routing. Okay, but what's the trouble here is it has routed all the tracks with a fixed route, a fixed width, that is 50. We set that to 50, the preferred width, so it has set 50 for all the routes, all the tracks. Right. So in order to route your circuit with the best possibilities, you can change your placement. You can change your placement, and this is something that you can monitor while routing the tracks all by yourself. Okay, you might need to ensure that some of the important tracks should be small and wide, and the others should be long and thin. And so the auto router might not do that job for you, so you need to do that all by yourself. So in the next uh, module, I'll show you how to step by step route this PCB, and if we can even squeeze the size further, and we'll finish it off in the next video. Till then, bye bye.